You're sitting at your desk, laptop open, staring blankly at a data structures problem. In your head, you hold a massive, crystal-clear picture of your future. Top-tier placements, a flawless GitHub profile, and a resume stacked with projects. Yet right now, you can't type a single line of code. And while you sit frozen, you watch peers making painful, visible progress, grinding through morning coding sessions and spending weekends building out hackathon projects. The issue isn't a lack of goals. The reality is that motivation is an emotion, making it an unreliable fuel for problem solving. Relying on it gives you massive spikes of energy after watching a roadmap video, followed inevitably by deep crashes the moment a problem gets actually difficult. Grab a pen and a piece of paper. We are going to physically write out a 6-month tech responsibility framework to replace your reliance on mood. Building a career on fluctuating emotions guarantees erratic progress. If you want lasting technical success, you need a physical, non-negotiable system of action. Step 1. At the top of your page, write down your core accountability question. Did I say I would do it today? This document outlines the mental shift successful engineers make. They stop asking the deeply flawed, emotion-driven question of, do I feel like it today, and replace it entirely with strict responsibility. This commitment applies even on your absolute worst, most discouraging days. If you are exhausted or frustrated, you still sit down and do the work, because an employer will never pay you for your mood. This split-screen chart illustrates why the shift works. Motivation, on the left, is highly volatile. It peaks and valleys constantly. Responsibility, on the right, is a steady, unwavering flatline that stabilizes your daily output, regardless of the external variables around you. Framing your daily coding sessions as an ironclad responsibility rather than a choice depending on your mood is the only way to build a reliable technical foundation. Step 2. Choose exactly one technology stack. Write it directly beneath your inquiry and bracket it with today's date and a date exactly 6 months from now. The instruction here is mandatory. Pick one stack for 6 months. Committing to a long-term timeline is necessary to achieve hireable proficiency. This rule prevents surface jumping, avoiding the urge to abandon your framework for a new technology when momentum stalls. Look at this calendar block. Dedicating an entire continuous grid of time to a single technology forces you to push past the beginner stage and understand the architecture you're actually working with. Intentionally restricting your optionality and locking yourself into a prolonged timeline protects you from the scattered focus that derails early progress. Step 3. Define one specific, tangible project you will build using your chosen stack and write it down. This must be a practical tool that you would personally use. Hoarding a folder full of half-finished tutorial files gives you the illusion of progress without the substance. Creating a functional, tangible application forces you into the friction of actual problem solving. Step 4. Underneath your project, write down your strict AI rule. I will not use AI blindly. Look at this code editor mockup to see this rule in action. Before integrating AI-suggested code into your project, you must manually type out a comment directly above it, explaining exactly how the underlying algorithm functions. The ultimate consequence of this rule is straightforward. If you cannot articulate how the code works in your own words, you are forbidden from clicking Accept. By severely constraining both the scope of your project and the method you use to leverage AI, you force genuine comprehension rather than settling for surface-level imitation. Step 5. Sign the bottom of your paper. This transforms your framework into a finalized physical commitment. Now, let's set clear expectations for the learning curve ahead. Right around week 3 or 4, you are going to hit a wall and inevitably feel incapable of solving the problems in front of you. That difficulty spike is completely normal. Feeling discouraged is a standard feature of skill acquisition, not a signal that you should quit. The mere act of finishing a project, despite facing intense friction along the way, is a standalone skill. It is one of the strongest signals recruiters look for to see what sets a candidate apart. Enduring the friction of completion separates successful, employable engineers from those who remain perpetual beginners. Take a look at the page in front of you. You now possess a physical document containing a 6-month timeline, a single stack to master, a specific project to build, and firm accountability rules. Still, it is easy to look at the timeline ahead and feel an anxious psychological burden that you are already behind peers who seem to be advancing faster. The source document reframes this directly. You are not behind. The feeling of being late is a false metric, created entirely by comparing your own internal struggles against the polished external successes of others. Your new, healthier metric for success is simple. The goal is strictly to be better than you were yesterday, independent of anyone else's progress. Tape this framework to the wall next to your monitor. Recognize that you are not late, and open your code editor right now to take responsibility for your first session.